heroes and heroines, and welcome to Practising Programming in C, the show where we think of something to do and spend an eternity trying to do it. In the last episode, I finally completed the PPIC lessons, which were insofar as, well, they still are, which are insofar as fantastic C programming exercises, really. It's his classroom, and I learned all about strings in that particular lesson. So yeah, now that I've done that, I want to go back and do this thing again, Boreh's Wheeler Transform. But before I start on it, I should introduce a couple of things. One of which is, actually, I'll just introduce the keyboard. It's the keyboard. So I got myself a nice mechanical keyboard, a Philco Madness Touch. I don't know if this is going to show up on the stream at all. Where's this guy here? Right, let me just pop over to the other thing so I can actually see what I'm showing off. So there we go. That's the old keyboard. You can see I've got the nice little Tux logo. I don't know if you can see that at all. There you go. It's got the nice Tux on the super key. And for like the F keys, I decided to get like some analog clock style keycaps. But the only unfortunate thing, I mean, I'm enjoying the keyboard so far. I haven't actually tried it out at a desk before, so this is going to be a first time trying it out on a desk. I've just had it on my lap so far, or had it on my laptop. Yeah, I don't know if I want the feet down or what. Yeah, I'm just not sure. Might have a play with that throughout the stream. Let's see. It's kind of interesting how different they sound. Because I think it sounded a bit more dull. A bit more a bit more muted, whereas it sounded a bit of a brighter sound. I don't know if I'm just imagining that. Yeah, it does sound a bit brighter with the legs up. Yeah, but the only issue so far is that the left shift key is a bit prone to sticking. So I've actually emailed them to see what they can say about it. And they replied asking me where it sticks, like where in the actual key press it sticks. Either the top, the middle, or right at the bottom. And it's kind of like at the top, so I don't know what they can make of that. Whether they can like advise me to sort of, I don't know, refit the keycap, or I don't know if you can even refit the actual switch itself. Or whether like they need to take it back and refit the switch or replace the entire keyboard. I don't know. But anyway, with a bit of luck, that'll be resolved at some point. Until then, I've just got to stick with it and just deal with the occasional stickiness. But without further ado, just check that I'm still streaming. Still streaming, no drop frames. And the mic is coming through alright. You can see the mic just on the very corner of the shot there. I suppose I could like put it there. Is that any good? Actually, am I significantly quieter there? I don't necessarily want to be too close. Because it's not necessarily supposed to be. Like, it's supposed to be like 30 centimetres away from you, actually. At least that's where they rate the frequency pickup thing from. And at 30 it's kind of like a flat thing. So that's kind of what I would prefer. But anyway, yeah, let us give it a whirl. Oh yeah, the other thing I was thinking of introducing was the web browser, but I won't bother. Just boring stuff. The music today is Jim Guthrie's soundtrack to Sword and Sorcery LP. And I don't know what I've got open, I've just got that. Oh, I've still got Hammered Hero open. That's from when I was annotating earlier. It's kind of interesting that that stayed up, like, while I changed the sound system over. So I bet if I'd have tried to play that video, either the sound wouldn't have worked or it wouldn't have played. But anyway, that's all just a bit of fun. Okay, so what's fun? I'm live. So yeah, BWT plus RLE. That's the topic. Which means I'm just back to doing all this stuff again. It's like an old friend. How do I kill this now? Okay. How many lines is this? It's 167 lines. So if I do the same implementation, like it shouldn't be too difficult. Okay. Right. See if I can remember how to actually do this. Because I've been relying on Insofara's stuff for like the last week. So I might have forgotten how to actually do any of this stuff. So it's if argc is less than 2, we want to was it p error? Or was it just fprintf? I think it was. I think it was fprintf. Yeah, it was fprintf, I'm pretty sure. Let's go to standard error usage. So this is going to grow as I do this implementation. It's going to end up with a bunch of stuff, a bunch of arguments that I'll be able to take. See if this builds. It does build. Okay. So if we do that again. Oh, right, cool. So the next thing I need to do is I need to read in my file. And this can fail, can't it? It's like fopen. Can I do this all in one go? So I seem to remember the malloc one I couldn't do in the same thing, I think. I think I'm correct in doing it like this. I'm opening it readable. If we don't get that, then we can p-error. 1, 2, 3. 1, 2, 3. F open args. I mean, it's just asking for another parenthesis. Surely not. Expected that. Let's just try this out here. No, I do seem to remember it was sounds of place parentheses around the thing. Oh, and also it's that, isn't it? If it's not an if file. Right. Okay. So what was the difference? There's no. So I was saying it like this. That's interesting. So, okay, right. God. Right, let's try again. Right, so that's the behavior that I want. So, I needed to declare the in file out there, and then do this stuff like that. Okay. So now we want to fseek to the end of in file. No offset, it's seek end, I believe. Then int size is equal to ftell on the in file. And then we want to seek back to seek set. Right. So we've got the size of it now. We want to malloc the, let's just do working buffer, right? So what is this? This is a string. It's like, I mean, like, because I remember that I was always like just reusing the buffer. Actually, in buffer. Let's stick with in buffer actually. So I need to declare that there, and then I need to say the error. I don't want to free at some point, so what was it? BWT called this? Yeah. Okay, so now that I've got the buffer, I want to read the file into it. Beyond Streetrub. I don't can close the file. So yeah, right, now that I've done this, just thinking ahead a bit here, I think it is reasonable to have a separate allocation for the in file and for the BWT matrix. I think that's reasonable. So we want to do, God, how do I do this? It's like something like this, wasn't it? And then it's another malloc. See if that builds. No, it doesn't. God, how did I do this allocation again? Was it just like this, maybe? Yeah. I think this is correct. If we get that matrix, sorry, if we don't, then compare error. Two and one. Okay. So if we have that, at some point we will want to free it. So now that we've got the BWT matrix allocated, we've got the space allocated for it. We've got the buffer which has got the BWT part of it. We now want to be populating our matrix. So we want to be looping over the Y and the X. And then it's like the first, or the second portion. And the first portion. Can I just, well, type it all again. It'd be nice, nice use of the keyboard. So the second portion is going to be, God, what is this? X-axis is equal to the inside, take away the y-axis. And while that is less than the in size, or is it less than or equal to? I think that's just correct like that. Oh, we had pointers, didn't we? So I want to point it into the BWT matrix. Although, do I need it? Yes, I think I do. I do need a pointer into it, I think. That's not so correct. Right. So I want to say that the value of BWT pointer plus plus is going to be equal to in buffer at x-axis, obviously. Yeah. I think. And then to the first portion, you say x-axis is equal to 0. Well, x-axis is less than the inside take away y-axis. Oh, that's just the same thing. BWT pointer plus plus is equal to in. I'm relatively sure this is correct. So that'll populate the matrix. So after populating this matrix, let's just oh, we needed to. Ah, yeah, we needed to replace the final character in the inbuff, wasn't it? Where's that? I want to say the value of the in buffer at the in size -1 is equal to a 3. What's that? Here begins the BWT. So at this point we've potentially populated the buffer, populated the matrix. Let's just try a printf in it. Although, was this at all informative? I can't remember if this is informative. Is that how you do it? Print off the in size times the in size. And it's the BWT. I think you do it like this. Point to the BWT matrix. Oh no, it's like this, isn't it? Yeah. Interesting. So we've got S's. Somewhere where the 6 got up on the trash bin. Okay. Which is not mallopped. Attempted for an address which was not mallopped. Where? What? BWT in buffer. Where is BWT matrix at this point? Yeah, I mean, it's obviously all completely busted. Attempted free on an address which was not mallocked. Because that, I mean, I'm only freeing the in buffer and the BWT matrix. So in buffer. Copies and so we're setting the BG pointer. This is what BWT matrix. Oh, hang on a minute, is this incorrect? Yeah, it's possible that this isn't quite right. Just try. Yeah, this was a weird one. It was like. Yeah, god damn it. Yeah, this is. Ah, hang on a second. Was it this, I wonder? And then this probably isn't correct. I mean, obviously the S's is not correct at all. The BWT pointer is going to put it at the start of the matrix. So it's probably just not marked. Pointer to BWT matrix in size. If we don't malloc it, we should have PO'd and return 1. Same here. So these are mallocked when we get down there. So any buffer. Interesting. Let's just see what doing this would show me. I mean, that was still probably the same out, yeah. Don't feed the input in the BW matrix. Unless, is it kind of like that? Seem to recall the malloc was a bit, the BWT malloc was a bit weird. Not the inside unless, hang on a minute. Can't just be like that, can it? Oh, ATAP car is not assignable. Right. That's the question. How did I do the in buffer malloc? Yeah, that's just in buffer like that. But because it's multi-dimensional. Should be defined like car. Ah, Ah, right. Oh, man. So, yeah, very close. Wait a minute. Oh, right, like that, I see. Right. Yeah, I thought there's something weird which I couldn't remember. Right, yes, okay, so... Points to BWT matrix. And all of that. There's an in-size worth of pointers to BWT matrix. I guess. Thank you very much, Mr. Harness. Thank you. Pretty weird since I was use, but yeah, definitely. So now what is the second problem here? It's print out a load of S's. So you want to be going down the y-axis. X-axis equals to in-size take on y-axis. The constant C9 as well, right? So it counts as variable length of array. Oh, right. Variable in the. Oh, right. Okay. Interesting. Good job on C99 then. So the in buffer contains the string. Somewhere more Robbie with the 6 gun, others with a fountain pen. So that's written out in the... Oh! C9 for the win, definitely, yeah. In pointer, I wonder. MSVC doesn't support it because it sucks. Of course. Indeed. Just bear with me while I cross my legs. And hope that my knee doesn't dislocate. So, yeah. These are the pointers. So, I do want the pointer there. And I don't really need... I don't think I need... Oh, hang on a minute. Yeah, right. Actually, no, that's not right. Yeah, right. Because I come in here and I want to say like the first thing I want to do here when I first come into this thing is to say that the value at BWT pointer, sorry, the value at, well yeah, the value at BWT pointer what, like the value of BWT matrix 0, it's actually like, I mean, it's sort of the end of the thing. Well, the end of the thing isn't going to see anything, but yeah, essentially. Oh, I'll tell you what. Let's step in. Let's step in and see what it's doing. So, x-axis is x-axis is y-axis insides. CGB. Oh yeah, of course. Cheers. I'm saving my bacon once again. Wow, hi pseudonym. Hello world. It's an honour to have you here. So basically what I want to have happen here is actually for this loop to not get entered. It doesn't, right, good. So now x-axis is equal to 0. X-axis is less than the inside minus y-axis. That's right. That seems right to me. And BWT pointer plus plus. So BWT pointer is currently at the start of the BWT matrix. It feels so weird to hear the word honour to be used in that context. So yeah, like if I print out, yeah, I mean BWT matrix is empty at the moment. If I just say BWT matrix 0, 0. Okay, that's interesting. But if I step over here, oh, it still doesn't have anything in. That's interesting. Or maybe the value at. Yeah, even so, this doesn't seem right. Can I put a pointer math on it? Incomplete types, try casting to a known type or void star. Well, let's just see what that is then. Although we have incremented it, so like, so that is an S. Try X. Access BWT matrix. Am I setting up the pointer wrong? GDB seems to be having trouble with VLAs. Right, okay. I don't remember having this issue last time. But then again, I also remember getting this loop correct the first time. Because I BWT pointer is equal to like, cause I do want it, unless, do I have to do it like that? No, I don't do it like that, because it's a 2D array. Like, so this loop anyway is gonna keep looping until we filled it up. What's actually, let's just print our BWT pointer again. Oh, it's still S. So what am I not doing? Oh, I'm incorrect in the wrong thing. God damn it. Gosh. Tell you what. That's more like it. Blimey. Don't think I've really done quite that bug before. Let's just see if I can spy this. Some is a little bit of fountain pen. Some fountain pen N. So, yeah, this looks correct to me. Okay, I'm going to say this is correct. Blimey, that took a while to find that typo. But essentially now what I need to do, so I've populated the matrix. I need to sort it and then take the last column. I think, pretty sure that's all I need to do. Sort, and then stuff the last column into the or something. So let's do the sort. So this is going to sort a matrix. So it takes the width, doesn't it? Yeah, width. And it's a car matrix. It's like this, I believe. Right, okay, so to sort this thing, it is a couple of loops. We are just taking the width and the matrix. Yeah, that's correct. J is the width. It's just J. And also it's like J is equal to, J is equal to I plus 1. I've got a feeling it's that. And then it's like if compare strings on those guys. So it's the matrix. Yeah, it's just this, isn't it? And also, do you pass the length to its compare strings? Got a feeling that I do. Pretty sure I do, yeah. If that is greater than 0, where's my parentheses? I think that's all it is. So for this compare strings, it's an int. Compare strings.
Oh, this is really nice.
So this takes the width, just the width. I'm going to take a yeah, it's also string, isn't it? So car and it's just like while it's just the lesson all over again. If they match, then we couldn't plus I. Oh, hang on a minute. Hang on, what am I trying to do here? Trying to say which one. We're trying to say which one should go before the other one. So it should return like A at I, take away B at I at some point. So yeah, let me just think about this. I'm taking in two strings. I need to say if they ever differ, isn't it? Right, it's if they differ. Then we return A at I, take away B at I. But we did also want to say if A at I is equal to the 3 thing, or B at I is equal to the 3, I want to return like kind of like the negative. So I will actually do the. Should I do that? Yeah, I'll do like this. Interesting. Incompatible to points of conversion. So, interesting. I don't really hear class strings. With matrix I. What's that? If compares. If compares means then we want to swap them. Hold on, let me return the opposite. And if we get all through this loop, then return 0. So yeah, we're now going through the. It's through each string, isn't it? Is that the end of the soundtrack? No. Oh, hang on a minute. Have I lost my audio? No, I haven't lost the audio. That was weird. I wonder why it paused. I mean, the audio still seems to be coming through, so hopefully it's okay. So yeah, we're swapping. So it's like JK. Let's listen to the word. So we just want to say car temp is going to be equal to the matrix What am I pressing? Right, that feels correct to me. So, right. So, yeah. I've got a printf here, so let's just try and sort it. Oh wow. So if I try and pass the in size the BWT matrix. Can I do that? Okay, I can do that apparently. Interesting. So, I mean, I have potentially sorted it maybe. It's always tough to tell though. But I mean, I suppose it wouldn't be too tough to actually just output the final column now. So, for size equal to 0, I is less than the width, or rather, in size plus I, in buffer at I is going to be equal to oh yeah, right. This is where I was using the axes. It was like y-axis. Where else could I have used that? Used it there. So the in buffer y-axis is equal to BWT matrix y-axis and k. Oh wait. Oh no. In size minus 1. Right. And then let's see if I can just print off here the actual in buffer. Right. Blimey. This looks very familiar. I think I might have done it correctly. Let's just test that theory. I'm going to do the manual sort again. So there's 60 of them. Have I still got the thing? Of course I have. So what am I missing out on there? Oh, I've got the N in the wrong place. What was that issue again? It didn't like the... It needed the new line thing, didn't it? I think that was what it was, wasn't it? So this is now 62 things long. Where am I? Okay. That. Right, so this looks the same to me. And the only difference is that this thing here, the end of line. So if I were to pipe this into XXD, how do you pipe again? It's X, yeah, there's my 3. Yeah, awesome. So, right, so my BWT is complete. How long have I been going? I've been going for an hour. Right, interesting. So, let me just pop on get some more music lined up. 13 minutes. I've got Dust Force in here. Oh, Factorio. Let's go for that. So that can be another hour and a half. So, yeah, I'm successfully BWT in it. Let us loft this out into a function. Right, this is all BWT encoding. We need the malloc separately. So here begins the BWT. Ah, right. So instead of doing that there, let's kind of. Oops. Do this down here. So yeah, we're passing the in buffer in, aren't we? So this is going to be a void. BWT encode. And it's going to take just the in buffer. It's going to take the matrix as well, which I'm going to pass in. So let's say it takes the width, or actually let's take the inside because that'd be just easier, and then it's going to take the in buffer, and it's also going to take the car BWT matrix, see if it builds. It does build. So let me just see if I can just straight up pass my in buffer to that function. In fact, let's print off. Yeah, I can do this now. Nice music, says Fiery. This is Jim Guthrie's soundtrack to Super Brothers Sword and Sorcery. And I actually have the soundtrack on vinyl, believe it or not. Maybe one of these days I'll kind of learn to play some of it. So this is going to be the original string. Right. So the original string is going to be that. Can I just yank this whole thing? And then this is going to be the BWT encoded string. And then between here, we want to say BWT encode. And we want to pass it the in size, the in buffer, and a BWT matrix. This is going to be so interesting. Is this going to work? Yeah, it is going to work. Wow. Yes. So I've encoded it as a BWT. And I do need to keep the 3 in there so that I can actually decode it. So that needs to stay. So let's write the decoder. So this is here begins the decoder. Wait, that's where I can just use that. So to decode a BWT encoder thing, all I have to do is, so I've got the string, I just need to populate another matrix, putting the encoder string into the final column. So I need to clear the matrix first of all. Oh, I'm going to declare the y axis. Okay. Yeah. It's kind of interesting to think actually what I'll have to do here. I suppose it's not the responsibility of the decoder to clear the thing that is passed. So
people will continue to get older, so it is no good waiting until
well, the y-axis is less than the inside.
to return to our youth.
Plus y-axis. So yeah, all I'm doing here is just clearing the matrix basically. X-axis less than the insides. What? Oh, wait. Okay. And I just want to romp over it, saying BWT matrix y-axis, x-axis is equal to null. Okay, so now I can safely pass this in. So rather than saying that there, let's say that here. So I can safely pass this into my decoder. Yeah. So I want to be looping over the matrix. So it's like yeah, so x-axis is equal to in size minus 1. X-axis is greater than 0. Is it greater than or equal to? It's greater than 1, greater than 0. Not greater than or equal to? Minus the x-axis. And for this, I want to actually loop over the y. Yeah. Why is it? Have I even declared? Yeah, I declared declared those guys up there. So I want to say BWT matrix at the y-axis and the x-axis are going to be equal to the in buffer. Have I got the in buffer out here? Hang on a minute. Yeah, so the in buffer is now successfully transformed. Yeah. It's going to be equal to the in buffer at y-axis. Yeah. And then it's going to sort it. Such as the in size and BWT matrix. And why is that? Why is sort finished up sorting like that? Completing like that rather. Or did it not? Oh, it didn't. That's just my typing. So yeah. It's going to go over that. It's going to, right, yes. And then I need to go down, after doing all this, I need to go down the final column looking for the 3 at the end of it. So it's going to be one loop. It's going to be for y-axis is equal to 0. Y-axis is less than the in size plus the y-axis. I'm going to say the BWT matrix with the y-axis and in size minus 1 is equal to the 3. Then we want to say for in buffer in buffer to x-axis. BWT matrix and y-axis, x-axis. Right, yeah, that has built. So now, wait, have I got another printf somewhere? So yeah. So this should hopefully be the BWT decoded with a bit of luck. Yeah, it is. Now, to be completely correct about it, it should actually be the in buffer at the in size minus 1 should then go back to being a new line. Wow. Kind of interesting that both times that I've done the decode, it's gone just exactly like that. Like, they just went right first time, somehow. So now on BWT decode. So that's going to take the same stuff as the encode. And the BWT matrix, so it's going to be is that right? I think that's right. So that's kind of Can I build it? Yeah. So if I try now to the BWT decode on the inside in buffer and the BWT matrix, it does still work. Wow. Gosh. I mean, how long have I got left? An hour and 15 minutes. I mean, like, the plan was to do BWT and RLE in one stream. I wonder. I just wonder if this can be possible. So a quick look at the string. NHH, 2 N's, 2 M's, 3 T's together, couple of I's, couple of O's. Whereas the original string, yeah, the original string would have had probably no runs, interestingly enough. I mean, I suppose strictly speaking, like a run length encoder like this probably wouldn't be that great for text. Like, you would definitely want something more like an LZ compressor, which I still haven't actually done. But yeah. Oh yeah, okay, so the in buffer and the BWT, yeah, they're fine. So here begins the BWT decoder. Right, okay, so the RLE encoder. RLE. How do we do this? You read your string in. You set your token. Output string. You need to calculate the possible size of it. So yeah, rather than having a matrix, you just need the size required. And this is an interesting one actually, because I can't do the RLE how I used to do it because the old one, it only dealt with zeros and ones, and rather than storing whether it was a 0 or 1, it just recorded the length of it. So I kind of suppose that this one has the potential to inflate the file size. Like if I don't do what Casey did with the literals, 'cause I'm not quite sure I understand exactly how that worked. But he had to, like, it would switch between like literal mode and run mode. And as I understand it, in the literal mode, so for example, for my string here, let's take this string. All of this, in fact, I think, yeah, probably the entire string might as well be in literal mode, because there's never like more than two characters the same consecutively. I mean, strictly speaking, this could probably all be in literal mode too. Apart from these 3 T's, they could benefit from being encoded as a run. I'm not quite sure I understand how How Casey figured that out. Yeah. Maybe what I'll do is I'll start off by allocating twice the size. I also need to oh yeah, I need to record the length of the string. So that's interesting actually. So let's give myself an RLE buffer. And then that's malloc the size of the in size times by 2. Add the size of an int, maybe. I think that'd be reasonable. Yeah. So if I'm a little buffer the in size times 2 add size of int. Okay. We are going to want to free that at some point. So assuming that we get that, we want to set up a pointer. We haven't moved the BWT matrix and I haven't moved the in buffer. Kind of interesting that. How have I been using? Oh, I've just read the in buffer into the matrix, didn't I? And then I just indexed out of it, I think. Or indexed into it, rather. Oh, and it's all above, isn't it? Yeah, like here. Okay. So these guys are still in the correct place. But I believe I will want to be... I will need an in pointer here. RLE pointer. RLE buffer. So this thing was... We want to set the value at RLE pointer to be equal to the in size casted to an int. I think this is correct. And then we want to set up our tokens and the counter. Where's the in buffer at the moment? The in buffer's at the start. The in pointer. So let's say, oh, we're entering the loop, aren't we, really? Yeah. I'm doing this differently as well. Basically what I'm thinking of doing is just saying, like, so the file will look like the size of, so yeah, it'll be like 4 bytes for the insize, or 8 bytes rather, 8 bytes for the insize, and then it'll be token, and then a count, and then from then on just like token count. That's kind of what I'm thinking. So we've done the insize. I want to say car token. Well, no, we don't want to say car token. We'll say we're looping over the entire in buffer. So it's while we have got a size for it. It's not null terminated. Which is kind of interesting. Gosh, how did I iterate through this, guys? I seem to remember that I iterated. I used the pointer to iterate through. Was it just while? Could I say while it was in exist? No, I couldn't do that because it was not null terminated. I've got the insize. I mean, was it just like for I? Was it just a for I loop, I wonder? Incrementing I. And then just stuffing the pointer. It probably was actually, it's probably just that. So the token and the counter. So this is iterating through the buffer, through the in buffer this is. Endpoint is at the start of the in buffer, so RLE pointer. Well, first of all, token is going to be equal to the value at the in pointer. Plus. And the value at the RLE pointer is going to be equal to token. Well, so Do I need the separate token value? I probably do, don't I? Or do I actually? This feels a bit disjointed actually, because I'm iterating through something with an iterator, but then I also have pointers floating around. If token is equal to the in pointer, plus count should be, oh sorry, count should be equal to 1 at the start. If you're serially encoding ASCII strings, you can make the encoder simpler and more efficient. Yeah, I am going to assume that. Yeah. I think encoding ASCII strings, you can. Simpler than this. Oh, simpler than the token count. Gosh. ASCII strings. ASCII strings as opposed to binary streams. So that means ASCII strings have like integer value. If every value is minus 128, you can use all greater than 128. You can use all greater than or equal to 128 numbers. How is it? Oh, right. Ah, instead of having them as ints, you mean? So, yeah. The R lesson 128. So that is true. If you can use all greater than or equal to 128 numbers. Yes, character. Interesting. So, does that mean that the count would then be So if you don't just store the total size, you can just stop when you hit 0. Can't type tonight. So you record the null terminator. So basically you're kind of saying that count would be count would be 128. Which in the worst case you just output the original string with a null terminator. Repeat the previous character that number of times. So I'll just type this out a bit. So if I've got right. So you're saying it'll output. Oh, do I see? And then, oh, hang on a minute. So yeah. So rather than recording, there's one of those. Because there is one of those. If there's a, I think this is the literal thing, isn't it? This is like, if I'm understanding it right. This is the stuff that Casey did. So you basically say, like, if if a token, something funny to do. Let's go at once. And it stored as a car, so a car is 1 byte. In this case, the original was also not from the original, yeah. Interesting. Okay, so let's try this. It's going to be 128 or 127. I mean, like, we're not going to output the car. Yeah, so when we come to the decoder, it's like, oh yeah, it's like if the thing is greater than 128, then we output the previous one. If it's the same as the previous one, then we want to increment the counter. Yeah, we want to get the count involved in it. Ah, right. Well, that's the point. Can we increment can we implement a car? Recording constant. No, no. Implicit conversion. So it's just here. This works mostly nicely by it. All numbers are in the form 0xx or characters. All numbers in the form 1xx or repeat codes. Interesting. Change values from. Oh, of course, cars are signed, aren't they? How do we do that though? Do I have to do unsigned car? Yeah, right. So we're basically saying that 128 is our. I mean, we could say that that's our two value. No, actually, no. Let's say it's the 1, because that means that we're repeating it. Repeat it once. Gives us a bit more. It gives us a bit more numbers to actually play with. So, I think I can't see if the 128. So right, so if it's the token is going to be equal to the in pointer plus plus. The RLE point is going to be equal to the token. So that means that we've put in the RLE buffer the token and we move the pointer around a bit. Now if the token at this point is equal to the in pointer, then we want to go into this situation where we're counting up the counts. But the trick is though how to actually, because if I do like a hang on a second. Yeah, we can actually. So we could say that the value at the RLE pointer is equal to the count plus plus. Without incrementing the pointer. And as soon as it changes, This has moved on. This has moved on. So the RLE pointer is set the token. And it has moved on, so it's ready there to put the count or the next token. Yeah, token. Right. And then I want to reset the count to be 128. Is that what I want? Or do I need to start it off at 127? I'm just wondering if this is going to actually set... I mean, I suppose I could try it. Let me just see what this is actually going to do. Let's print off the count plus plus, and let's do it. Actually, let's just do the one for now. Is this going to even run? I wonder. Count is 128. Yeah, I mean, basically all I'm trying to work out here is whether whether this thing here will set, so say like I've declared count to be equal to 128 up here. I'm wondering if this assignment here will set it to be 128 and then increment, or whether it will set it to 129. See if I can get down to there. So it's print off 128. Okay, and then at this point, count is like towards it. Okay, so it does do that then. So let's go set it to 128. And then increments. And if token is still equal to the end pointer, not sure why that was crashing though. I mean, I haven't finished it obviously. As I go to 0 bytes to the right of 60 byte region. Okay. Yeah, count is going to be equal to 128. What else was there? Oh, it's just out. It was outputting the count, wasn't it? Yeah. Oh, was it? See if I can see what's actually crashing there. No stack. Pointer. Yeah, it's going to be accessing something that shouldn't be accessing, I imagine. Token is equal to in pointer. Am I not setting the token correctly? Well, I mean, I'm just going through the buffer. Token is equal to the in pointer plus plus. The in pointer is at the start of the in buffer. RLE pointer is just after the in size bit. RLE pointer equal to that token. If the token is equal to the in pointer plus plus, so it's going to get it's going to compare against the value at in pointer. And if that's the same, then we say the value of the RLE pointer is equal to the count, and then it increments that, and then it goes back and tests if the token is still going to be equal to the same thing. So I need to do that, and then I need to say, well, hang on a minute. It's going to, no, it's going to do, no, that's completely rubbish. Because it's going to it's going to do this. The value of the RLE pointer is equal to count plus plus, and then it jumps out and goes back to the loop and says token is equal to in pointer plus plus. That is equal to token. In pointer plus if token. Token, am I testing the right thing? If token is equal to in pointer plus plus. Probably not actually testing the right thing. It's probably more like, well, is it? We've set the token to be equal to the in pointer. Yeah, that's just going to keep testing, isn't it? Because I'm not incrementing anything here. Well, hang on a minute. No, I am incrementing the in pointer. Oh, that's possibly a bit busted though. Let me just see if I can catch where it's actually dying. So it's probably, I don't know, X is with code 01. Equal for other channels with the buggy address. Original string, so we can get down to this loop. Let's Run down to there. Continue. Ah, right. Just somewhere within this loop. Just dying. Oh, hang on a minute. That was the first time through the loop, wasn't it? So if we run to there. Now it should die, right? No. So, what is the... I can kind of believe that that's alright. Alright. Let's put an S out again. So I'm not incrementing something correctly. Oh, hang on. What am I actually working on here? Yeah, because the RLE again. So decode. So yeah. So I'm working on the right. I am working on the original string. So I've incremented the in pointer twice. So, Tell you what, before I do anything interesting, let's just if-zero this for just a minute. And just say for this, just set the value at the in pointer, sorry, the value at the RLE pointer plus plus to be equal to the value at the in pointer plus plus. So that should just put it straight out. So, yeah. Rather than doing that directly, then let's say if token is equal to the value at the end pointer plus plus, they would say that the value at the pointer is equal to the token so yeah, so by the end of that loop what was it again? XS. This is kind of like the size. Got any Where's the new line coming from? Oh yeah, it's got a new line at the end of the string. So that's working alright. We've incremented pointer once. Maybe it's just this. Is that the only difference? Probably not the case if it is. No. How was I doing this comparison before? I want to read from the in buffer, and I want to set the token to be that. So the token is that thing, and I want to read the token. What am I testing? Testing the wrong thing, aren't I? It's really... So we have moved on. It's like if the value of the RLE pointer -1 is equal to the token. They want to set the value of there is equal to the count plus plus. Otherwise, we want to increment the pointer kind of. I suppose it doesn't explain why I'm actually writing over the end of it though. Or whatever the actual error is. Oops. Right, okay, so I'm not dying now. I am if wand. Okay. So interesting. Let's see if I can print off this RLE buffer. What? Okay. So now let's say, rather than doing the decode, right. There's no oh, hang on a minute. Yeah, well, that's interesting. That is interesting. There's no IN. Let's just print out. Oh yeah, and you don't need to record the size as well. You were saying, so yeah, let's just stop doing the size then. Where's that? Yeah. Smell up the in size. +1. And at the very end, I want to say that the RLE buffer at the in size is going to be equal to a null character. So these are the same still, interestingly. So I'm obviously not testing correctly. What am I trying to test? RLE pointer is equal to token. That's interesting, okay. See exactly what I'm doing here. It's like this test here is not, it's either not succeeding or it's not doing what I expect it to do. Is that the right one? No. So at this point, the value at RLE pointer, let's say, well, what is it? That is a -16. Right. Token. So yeah, it's going through here. Right, okay. So they are the same. Which isn't correct. Yeah. Yeah, it's this thing again, isn't it? It's like, you know, the things are sized, so I can iterate up to the size, or rather I can't iterate up to a null because I don't have one. Where did I do the null actually? I did the null at the end. Int I is equal to 0. Where's the... Yeah, but I do want to be iterating through that. And I don't necessarily want it to correspond with the RLE pointer. This is incrementing every time. It's incrementing there. So it suggests to me that I need to be doing this. But then that'll get romped over by this guy. What's the early point? What did I just do there? That's -1, so that was... Unless we say... Well, no, well, there's a... So we're going to go through that. Oh, hang on a minute. While they're equal. Right. Because you want to increment the counts multiple times, potentially. No, that's still not right. No, that isn't right. Because I'm supposed to be iterating through the in buffer here. Right. Cars equal to tokens. What's token? Token is that at this point. Where's token? Token is set in the loop. So that's set to the first end. In point is incremented. RLE point is just after the... Well, it's just at the start now, actually. So set that to be the end. And increment it. And then we see if RLE pointer at the previous index, if that is equal to token, and it's always going to be equal to the token the first time through, it's never going to test wrong. So how do I do this? God damn it. Okay, see, this is a stupid test. It's always going to be that. I want to go through. So to go through the in buffer. To go through the in buffer, put a thing in there, and then increment that. Increment the in buffer. The in pointer. And then I want to test the new in token. The new in pointer against the token. Because the token is equal to the thing down there. And then increment, and if it is the same, then we put the count there. And then we increment the pointer. And then we test again. So what was that? It was go in. Let me just write it in English. Because we'll set the RLE pointer. We'll set the token from the in pointer. Set the RLE. From the token. And then we want to, well, okay, so rather than doing that, set the token for the endpoint, so then we want to test if increment the in pointer increment the in pointer test the in pointer test the endpoint against the token if they match. Set the RLE pointer to equal the count. And here we want to do another loop. We want to be saying if they match, set the to equal the count. And then we want to increment just the increment the in pointer, testing the in pointer against the token. If they match, set the if they don't, set the if they don't, increment the I the token. Where am I testing? Where am I setting the token? Set the token for here. Increment the in pointer. Oh, wait a second. Oh no, I still need to get the get the token down here, right? Gosh, am I understanding this right at all? So I don't want to be testing. I don't want to be setting the token each time I increment, do I? I want to be setting first of all out here. The token should be equal to the value of the in pointer. Right. I only want to be setting the token in the case that they don't match. If they don't, so yeah, right. So if they match, set the R pointer to equal the token. And speculatively increment the counter, I would suggest. If they don't, increment the R and set it to equal the token. And then we want to wait a minute. RLE pointer plus is equal to the token, and token is equal to the value in pointer. See what that does. Nothing again. Where am I incrementing the in pointer? Nowhere. Set the token from there. Plus was I? This feels so janky. So I've just got a lot of ends now for some reason. What was that thing I just did? What's that? Token. Yeah, I just feel like I'm super not like on top of this at all. Just ridiculous. It's just such a small little thing. So the token to be equal to the value at the endpoint of plus plus. So where's the actual loop happening? Just increment the end pointer. Just the end pointer. Just the end pointer. So increment the end pointer and the RLE. Okay, so set this from the token. So that we don't. Set the token from the endpoint and set the RLE plus plus token. So the RLE plus plus from the token. So the token was set from the endpoint. Increment the endpoint plus, yeah. So that's kind of done. Test the endpoint against the token. Oh, the end pointer. God damn it. Yeah, right. If they match, set them that's equal to count plus plus. Else increment the RLE pointer. Set it to equal to token. Increment the end pointer. Where's token being set? If they match, either way we need to increment the end pointer. Just plus. So just want to fill my little buffer. stuff. So what's that? That's just the inside. What's the side? That would increment it twice, probably. Hang on, if... well, actually, either way, we're incrementing the in pointer. Maybe not, actually. I don't even know what this is doing now. Is it just because of this? Yeah, I mean, I suppose I can't really have incremented the in pointer until I actually enter the loop. And will this... Yeah. Yeah, I don't seem to be able to kind of get this logic down just in the moment, so I might have to call it a day there and resume tomorrow. So the token from the in pointer to the... Because we do need the token to kind of be a kind of intermediary thing. I think. Well, I mean, maybe we don't actually. Maybe we could just say... We could just index straight into the RLE pointer. You know, like if we just say, if we get rid of the token entirely, what was it? Was it in pointer, wasn't it? Yeah. Yeah, I mean this isn't quite going right. Rally pointer. Yeah, I don't know. I think I'm going to call it there and come back to it tomorrow. Yeah, but I mean that wasn't a totally wasted stream because we did do 221 lines of code, and we did do the full Borders Wheelie transform, which was quite nice to get that done. Did a nice little sort, got the encode, decode again went really smoothly. So yeah, let's call it there. And with a bit of luck, tomorrow actually should be a bit of a special day in the Handmade Network. I would love to announce something, but I don't know whether I should. So, and I haven't been cleared to do any announcements, so I won't. But we may have a cool thing in store. But yeah, anyway. Cheers for watching. Cheers for being awesome and helpful and heroic and patient. Sitting through 2.5 hours of me stumbling through RLE, basically. Now that I've nailed the BWT part of it, it's now back to stumbling through RLE. Guess that'll be the perennial problem. But anyway, yeah, until tomorrow, farewell for now.